Metal detector surge coil. The first thing we need to do is make a coil former. I'm going to make a simple mono-loop coil. For this we'll use roughly 20 winds of 0.5 insulated copper wire on a former I made from wood and lengths of aluminium wire. There are several ways to make these coils. I just like doing it this way because it works best for me. I picked up the insulated copper wire from JCar Electronics, and I will neatly tape the winds into a nice, tight, orderly bundle, then scrape the insulation off both ends to allow it to be soldered to the main connecting wires later on. Then it's a simple matter of taping it all into a nice, neat and straight bundle. There are of course several ways you can do this, but using a sharp knife is not one of them. I found the best way is to use a dull serrated knife, as shown here. Just ensure that you remove all the insulation from all the sides on both ends. It's just a simple matter of taping the wire into a nice neat bundle. Just use little strips of tape and place it in as many places as possible, and keeping the bundle nice and tight. It's a simple matter of inspecting the bundle of wire, making sure that it's straight, no kinks, no broken insulation, shorts, etc. When the metal detector circuit is connected to the coil, it will create a large magnetic field which can virtually penetrate anything which is not metal. In my opinion, this design allows for very precise separation from the ground noises and metallic objects. In other words, the circuitry seems to be better able to filter out unwanted interference in medium mineralized goldfield areas, salt water and normal ground conditions overall. But here is an interesting question for you. Why did I use an 11-inch or 28-centimeter coil? The larger coil, the deeper it can pick up larger objects, but the smaller coil is the most sensitive to small gold pieces. So what is the easiest way to get the best of both worlds? Use a medium-sized coil, apply more power to the coil, use more wire and windings, use thicker wire, or distort the shape. Stop the video and now choose one. Answer is 5. Distort the shape. We're going to bend the shape of the coil from round to elliptical. We'll show this in the next video. We'll also show how it affects the sensitivity and depth, and even introduce it to light instead of sound. The first thing we must ensure we do is turn off the television and all interferences. Then we're going to hook up a power supply to the metal detector circuit. It is controlled by a trim pot, an on and off switch, and it is hooked up to some headphone speakers. We will use a variety of test objects including gold, and it is finally hooked up to the metal detector coil we made earlier. My first question is, why do we turn the TV off and remove all metal objects? Is it because the detector will 1. Overload, 2. Become unstable, 3. Fail to work, 4. Temporarily shut down, or 5. All of the above? Please stop the video and choose one now. Now we are simply going to turn the detector on and use a variety of test objects. I'm just going to let the detector warm up a little bit and get the test items ready for testing. Now watch what happens. What happened? Stop the video and choose from one of the following answers. Sometimes you've just got to eliminate all possibilities one by one, always remembering it could be the simple answer that's right. Okay, it's just a simple matter of replacing the batteries and switching it back on again. Okay, nothing's happened, so we're just going to have to switch it back off and switch it back on again. Apparently the detector circuit didn't fire up. We're starting the test off using scrunched up pieces of aluminium foil of various sizes. As you can see, the detector coil is not very sensitive to small pieces of aluminium foil, but responds quite nicely to a larger piece. And much the same if we use a larger sheet of aluminium foil. Now we're going to test the coil using a variety of solid objects. First, a very small piece of gold. As you can see, it's very little response. Maybe a little as it passes the coil. And then just under 1 gram piece of gold. Not much better. Still having trouble with the sensitivity. A larger chunk of gold in quartz. Bit better again. Okay, now we'll try a solid gold ring. As you can tell, it's very clear signal, great depth. And now we are going to hook the audio system to an LED light instead of sound. I'm going to use a variety of test objects, and what do you think is going to happen? The light will blow out, the circuit will overload and shut down. It will respond with exactly the same as the audio hookup. It won't work at all, or none of the above. Stop the video and choose one. The answer is number 3. It will respond with light exactly the same as the audio hookup. Very small piece of gold, virtually nothing. Slightly larger piece of gold, under 1 gram, not much at all as well. And now we'll use a larger piece of gold in the quartz, and as you can see, it is responding better, the same as before. Small piece of scrunched up aluminium, very little response. A larger piece of aluminium foil, as you can see, it's a little bit better again. Much larger piece of foil, and we're getting a pretty good response. Now we'll try the solid gold ring, and as before, great depth, very powerful, good clear signal. Now I have hooked it up to the audio circuit, distorted the shape, and we're going to listen to what the less than 1 gram nugget sounds like. As you can hear, we're getting a much better response. But the most interesting thing here is that we've actually increased the search width and the depth at which it will detect a gold ring. So now, what do you think will happen if we place on top of the coil a large sheet of aluminium foil? Will it overload the detector circuit, or will the detector coil simply penetrate through the aluminium? Or maybe the detector circuit has just shorted out. One possible answer is that it is simply not penetrating the aluminium foil. But if that's true, look what happens when we wrap the entire coil in aluminium foil. On the less than a gram gold nugget, it actually appears to become more sensitive and more stable. Here are some possible answers for you to ponder while I go about making the third part of the video. The answer is that the aluminium foil actually makes an effective shield against the effects of water onto the surge coil. There are many configurations available. I have presented here the mono-loop, which is commonly used in mild mineralization areas. Here is a drawing of the double D design, which is commonly used in heavily impregnated iron areas, such as goldfield areas. The transmit coil is separate to the receive coil, and it is designed to penetrate and filter the ground like a blade, rather than a cavity, as in the mono-loop design. Now we are going to cast the coil. Here are some of the problems associated with making the coil. 1. You should consider how and what you're going to use to join the coil to the shaft, keeping in mind that a metal bolt and nut will affect the detector function. 2. The casting material must be waterproof and be able to attach to an adjustable shaft to suit different lengths and different people. It must also be light and very strong without being brittle or prone to cracking. No more than 300 grams, otherwise it will be unbalanced and tiring to search for long periods. The material used must be of the highest quality, impervious to weather, non-metallic and available. The wire coming from the loop must be protected from moisture and breakage and from constant bending. It is also a source of unwanted noise because it can move or get tangled among the bushes and such. Most importantly, the casting material must not stick to the cast in any way. So how can you eliminate most of the casting problems and create a very strong, light and versatile search coil? Use curved plastic tubing to house the coil wire. Use timber and glue to house the coil. Make a cast from timber and silicon to house the coil. Encase the wire in the stem and cast the coil with the stem. All of the above or none of the above. Stop the video and choose one. The answer is 5. All of the above. Housing the coil is only limited by your imagination, but remember it should be waterproof and look the part. Casting the coil upside down from a clean painter's bucket is one way of achieving this, as the paint and casting material will not stick to the plastic, but it does have its own set of problems. The coil connecting wire and the brackets that connect the coil to the stem must be carved into the bottom of the bucket. I used hot melt glue and carved timber stuck onto the bottom of the bucket. If you use this method, you'll get a great finish, but you'll need to coat the carved timber parts in a non-stick material. Silicone and ice cream container plastic works well here. The cast shown here is very well coated in a kind of wax to stop the cast from sticking. You'll also need to cut some lengths of the plastic to be used for the inside design and remove some excessive cast material and potential weight from the larger coil. I used a set square and traced 2 lines, 25 mm apart from the bottom of a bucket with a fine point permanent marker, one for the cast and one to be used as the inside pattern. Remember to allow for the cutting thicknesses when marking. I use a bending plastic ruler to draw the lines for the lengths of plastic and used hot melt glue to hold them in place. You must be very patient and ensure that there are no leaks. Otherwise, the cast will be very difficult to remove and you will most likely destroy both the cast and the mold in the process. Before the cast material is poured into the cast, the connecting wire must be soldered very well onto the coil so it cannot be easily pulled out. A large solder joint is ideal here. Then feed the coil connecting wire down the hole and seal it off well with hot melt glue. It is very important that you ensure that the coil wire is not touching the case. Otherwise, when the finished coil is used in water, it will enter through the cast and cause the detector to become very unpredictable and effectively rendering the coil useless. The same color zip ties are an ideal use here. Also test the seal of the cast with water before mixing it, because the material can be as thin as water when it's not set, and any leaks are going to make a mess inside and outside your cast. Another problem is that if you don't mix the casting material absolutely 100% correctly, the cast will either never solidify or will suddenly overheat and melt all your hot melt glue, effectively destroying your mold and your work. I used araldite at 25 to 100, or 2.5 30mm plastic shot containers of hardener to 2 150mm plastic cups of araldite, because it is tough and virtually unbreakable. Be wary, as most cast materials are too brittle and will break when you try to remove it from the cast, especially when it's not fully cured. If you get it right, however, you will be left with a great coil cast with connecting brackets, wire support and an easy lift out large coil, ready for painting. Then all you've got to do is put a rubber boot on the coil connecting wire. I used a backing for a headphone jack and held it in place with aquarium silicone. However, if you use a coloured dye in a cast, there's no need to paint the coil and you'll get a lightweight, solid, shiny coloured plastic coil that is 100% waterproof and ready to go. Also remember that there are many ways to make a detector coil. Can you think of another way that will work even better than the one I was presented here? In the next part of the video I'll present a more practical, effective and powerful surge coil, or as some people call it, a detector loop. Let's think of how we can remove some of the casting problems while still making a strong and sensitive loop. Can we use curved plastic tubing to house the coil wire? Or styrofoam and glue to house the coil? Or make a loop from timber and silicone? Encase the wire in the stem and cast the coil and stem together? All of the above? Or maybe none of the above? Stop the video and choose one. The answer is 5, all of the above. Housing the coil is only limited by your imagination, but remember it should be waterproof and look the part. Here is a picture of my test loop. The silicone coating keeps it waterproof, and it also seems to help with the sensitivity somehow. You can use any method to house a coil that doesn't require metal, just imagination and knowledge. This design is simply cut from a solid piece of 25mm timber with a jigsaw. Simply draw the coil on the timber, drill a hole on the inside for the cutting blade for the jigsaw, then put a sheet of timber on the bottom and glue it as your base. Remember you will need to fill that hole in after, because we're going to use that piece you've just cut out. All you need to do is shape and sand the bottom of the template, and there you have it, your new loop design. But how can you place a non-stick surface on your template so it won't stick to your mold, and what can you use to fill the gap which will not make your cast stick to the mold? Use silicone on the mold and grease to stop your template from sticking. Apply casting wax to your template and pour some casting material to fill the gap in the mold. Fill the gap with silicone and cover the template with cling wrap. Coat the mold with casting wax and cast the coil straight from it. Or maybe none of the above methods will work. Stop the video and choose one. And probably the simplest answer here is number 3. Fill the gap between the template and the mold with silicone and cover the template with cling wrap. When the silicone is set, the cling wrap will easily peel off the template and you will be left with an almost perfect silicone rubber cast. Casting material will not stick to the mold at all, and you will be able to put a small flat butter knife underneath the coil to remove it from the mold. Easy. It will be 100% waterproof, strong and problem free. But what about the brackets to hold the coil and the connecting wire? Why not mold them together inside the stem and set it on a perfect sweeping angle? We have done many tests on this design and there are no disadvantages unless you jam the coil in some way and force it to bend. Even then it can be straightened with a hot air dryer. The ideal angle at which the search coil should be set at is 50 degrees. Or if you like, you can cast the same color brackets into the cast and hold it together with the stem while it sets, and simply drill a hole and place a plastic bolt and nut after the cast is set. Or you can easily use a very thin stainless nut and bolt. Silicone doesn't stick to small plastic cups either, so I simply filled them up with silicone and used it as part of my inside design.
It's been pretty stable. Very stable doing here. What we're going to do is we're going to dig some of this soil here out and take it back just to sample it, because we haven't found any gold in this spot here today, but I dare say that there might be really fine gold worth panning, so we'll have a go at doing that in a little while. It's good having a small coil too, you can get it into the nooks and crannies.
In the next video I will show you how to make the control housing, the adjustable shaft, and finally I'll do the circuit board.